Hi everybody. So today we're going to look at our second problem solving lesson, and we're going to continue the idea of that input processing output model of problem solving that we learned about in the first problem solving lesson. But in this time we're going to start looking at more complicated problems where it may be beneficial to start writing the code or doing that IPO method for smaller chunks of a larger problem. Okay, so we're just going to do like one example of that. So we're going to make a game similar to the game of NIM. I'm not sure you've ever heard of that one before, but my variation goes like this. So we're going to start with a certain number of coins in a pile. So let's say there's going to be between 20 and 50 coins in this pile. Okay, it's a two-player game. We're going to play human versus computer. You could play human versus human too if you wanted to. But the idea is that you want to force your opponent to pick the last coin. All right, so the player that picks the last coin is the loser. And you can choose to pick 1, 2, or 3 coins at a time to remove. Okay, and then you'll alternate doing that back and forth until finally somebody is going to figure out how to make it so that their opponent will make the final move and have to take the last coin. Okay, so we're going to code this in parts. So take manageable steps that we can kind of accomplish little bits at a time, test our program, and just kind of make sure that everything is working properly before moving on to the next step. It's way easier to do that than, say, to write a whole piece of code, have something go wrong, and not know where the actual problem is. So let's get certain things working and then work on modifying them so that we can finally get to the whole game that's complete. So I think the first part of the game that I want to deal with is just let's get the random coin starting to start the game. Okay, that should be pretty straightforward. I mean, I could go through the entire input processing output for every part that I'm doing. Perhaps this one it's not really worth it because I mean we'll just generate a random number. So I'm going to need the random library. I'm going to need a variable to store those random coins in. The command to do it is pretty straightforward. It's just a random int. It's going to be an integer that I want to generate, and I can easily test that pretty straightforwardly in my IDE. So we'll get that started. And I guess I'll comment as I go, just so we don't have to go ahead and document the code later. Okay. So we'll generate the random number of coins. And maybe we'll store that in a variable called num coins. So between 20 and 50. Okay. And just be mindful of our output here. This is a simulation that's going to show on the screen, so we've got to have some type of prompts indicating what is actually happening in the game. So maybe something like there are num coins in the game. Okay, so the user will know exactly how many coins there are when the game starts. Okay, and we can test that. And okay. Obviously, we're getting a whole bunch of different random coins every time we run our program. So that seems to be working correctly. So again, little bits at a time, right? Think about it. Think about whatever processing you need to do. All right? Write the code, test it, right? Then move on to the next step. So maybe the next thing I would want to code that might be a reasonable thing to start with would be to get the game to kind of work as expected. So have at least one player be able to choose any number of coins, and then the game reduces the amount of coins in the pile after each choice. And then it eventually will stop when there's no more coins left. So, and maybe we won't deal with the fact that we have to deal with 1, 2, or 3 coins right now. Let's just get them to get the input from the keyboard and then reduce the number of coins and stop when we're supposed to stop. So this is a little more complicated, so it might be helpful to think of what kind of processing you would need to do for this code. So you've got to get input from the user. So we need some user input. So maybe I'll call that variable like player choice. Okay, and then I need to subtract, right, the player choice from the number of coins. Okay, and then I'm going to need to check whether the number of coins is still positive. Okay? And if so, I'm going to just maybe display the remaining coins. And if it's not, then I'm going to end the game. Okay, because that would mean that you lost at that point. Okay, and I guess all of this needs to be some kind of infinite loop structure. Okay, because it's got to continue to do that over and over and over again. All right, so it's kind of my processing that I would need for part 2. So let's go in and write that code. Okay. So back to our IDE. I don't have to change anything here. Okay. So we'll start with my infinite game loop. Okay. So I'll use a break statement eventually. Okay. So let's get the player chooses the number of coins. Okay. So that's just a simple input statement. It's going to be an integer. So enter the number of coins to pick. The prompt can be whatever you want. Okay, so now we'll reduce the number of coins. One strategy you might want to do instead of just like writing it out on paper is to do your processing as just the comments, right? And then start filling in your code after. Right. So my new number of coins is going to be my number of coins minus the player's choice. Right. And then we'll check if the game should continue or the player loses. Right. So if the number of coins is greater than 0, the game is still continuing. Okay. So I'm going to need to tell the user who's playing the game how much is left. So we'll say there are num coins left in the game. Okay, so the computer, the second player would know exactly what's going on. Okay, and otherwise, we would assume that you took the last coin. Now I'm using greater than here, and I'm going to eventually limit my choices that the player choice can make. So it's either going to be bigger than 0 or actually equal to 0. I'm not going to have a scenario where it'll be less. Okay. So this would be you took the last coin. You lose. Okay, and then we'll have to break out of my loop. Okay, so let's see if that's going to work here. So I'm starting with 45 coins, and so I can pick 3 coins. Okay, I can pick 40 coins or 30 coins if I really wanted to, because I'm not limiting right now. But 3 coins left in the game. So if I picked 4, it should stop, right? Okay, so I've got kind of a basic structure going on now. That's good. I'm reducing the number of coins that the player is using. So maybe in the next part, we should validate the user input. Okay, so let's maybe. So I think it's pretty easy to check whether 1, 2, or 3 coins was inputted, but I don't want the program to just stop if they choose a different number. I need to have it so that my program is going to tell them you can't pick that many coins, and then it should ask them again. So it's going to continuously ask until a valid input is chosen. So we have to kind of think about what choices are not valid and what choices are valid. So if the input is bigger than 3, that would be not valid. If it's less than 1, that wouldn't be valid. And you can't pick more than the number of remaining coins that exist. That would also be an invalid choice. Like I can't, if there's only 2 coins left, I can't pick 3 coins, right? So that would be an invalid input. So I'm going to have to use some type of, again, another infinite loop that is going to just continue to operate until I get a valid choice. Right? So maybe we'll try it like this. So we'll have our infinite loop. Okay, so we'll get the input. Okay, and we'll check for an invalid input. So check for invalid. So remember, our invalids are greater than 3, less than 1, or greater than the number of coins remaining. Okay, and if invalid, I'm just going to display a message. Okay, so print maybe not valid, choose again. Okay, but if I don't get an invalid input, which means I got a valid input, I can break out of my infinite loop. Okay, so basically this code is breaking when you get a valid input. Okay, and it's just choosing to print not valid when you get an invalid input. Okay, there's probably a whole bunch of different ways to do this. This is what just came to my head right now. So let's go modify our existing code to see whether we can get that to work properly. Okay, so this infinite loop needs to be like here. Okay, and then I shouldn't have to change any of this code here. So we will surround all of this with another infinite loop. We'll just need to indent. Okay. Starting to get out of space. There we go. Okay, so now we'll say if player choice is bigger than 3, or player choice is less than 1, or the number of coins minus the player choice is less than 0. Okay, so that would be you're picking more than you're allowed to. Okay, so if any of those 3 happens, I'm at an invalid choice. Okay, and we'll print not valid, choose again. All right, and otherwise I do have a valid choice and I can just break out of this input loop. Okay. Okay, let's see if that works out the way we are expecting it to work out. Okay, so we'll run our program. So there's 27 coins. So let's see if I try to pick 4, not valid, so it's choosing again. Okay, can I pick 3? Yes, so 24. So now it's going to ask me again, and it did. Okay, it broke out of that loop, and then it continued down here. So can I pick, say, 0 coins? No, not a valid choice. Okay. Can I pick, how many coins are left? 24 coins. Can I pick 25 coins? No, I'm not allowed to pick 25 coins. Could I pick 24? Okay. So what should I do there? Again, actually that kind of makes sense. I wouldn't want to be able to pick 24 coins because I've lost, but at some point I'm going to have to be able to, I might have to pick the last coin, so I should probably allow that to be less than or equal to at some point. Okay. All right, so that part is seemingly working properly. Now we've got to code in the computer's code. Okay, so here's our computer player. So we've got to design this code so that the computer can pick an appropriate amount of coins. And it's got to have some type of intelligence to it because I mean, I think it's pretty straightforward to just have the computer pick a random amount of coins, but it should try to win if it has an opportunity to win, right? Because if there's more than 3 coins, it really doesn't matter. Have them pick 1, 2, or 3 coins. But if there are 3 coins left, then the computer can win if he picks 2, right? If there's 2 or 1. If there's 2 coins left, he's got to pick 1 coin because then he'll win. Okay. If there's only 1 coin left, he can't pick anything else. He's got to pick that 1 coin. So we do have to build in some type of little kind of decision structure in there for the computer to follow. So So if the num coins is 3, or sorry, bigger than 3, just pick a random 1, 2, or 3. Maybe there's a better choice than that that will ensure that the computer will win more often, but I think that's good enough for now. Okay. If it's equal to 3, then pick 2. Right. If it's equal to 2, pick 1. If it's equal to 1, we have no choice. We have to pick 1, right? Because I can't pick anything else. So that actually these could be combined, right, with an OR statement there. Okay. So that's going to determine how many coins the computer is going to pick, and then after we determine that, we've got to reduce the amount of coins, and we have to check whether there's any coins left or not. Okay, so check, just like we checked with the player. So check for a win or loss state of the game at that point. Okay, so that's not too bad. This is a couple if statements for us. So we'll go back to our IDE and we'll write that piece of code and see if we can get this game to finish off and work. Okay, so where's that going to go? Well, that's got to, the computer, sorry, the player is here, so the computer picks next. So we're going to go down here. All right, move that back up. So computer's turn. So the computer choice. So if num coins is bigger than 3, we'll need a computer choice. That's equal to a random number between 1 and 3. Okay. And we'll make it an if-else structure. So if the num coins is 3, that's where we're picking 2. And if num coins is, remember, if it was 2 or 1, then we're forced to pick 1. Okay. All right, there's no other options. That's the only things that can happen. I don't need an else there. But I should display to the person playing what the computer actually picked. Okay, so it's just a simple if statement. So the computer takes C choice coins. Okay, and then we'll reduce the number of coins, same we did before. So num coins equals num coins minus the computer choice. And then we'll check for a winning state. That's the same thing as up here. So I can just copy that, but it's not the player losing, it's the computer losing. Okay. So if the num coins is 0, we'll continue the game. Okay. Otherwise, computer took the glass coin. You win. Okay. And I think that's it. So that should be the kind of completed version of our game. The only thing that would be left to do would be to test it. And I think I will leave that up to you to go ahead and test that. The next activity under here is to go through and kind of find all the different values that you could try to pick and to kind of do a thorough testing job, right? So kind of the point is, you have this input processing output model, right? But break your program down, make manageable tasks that you can complete one at a time that kind of build up your program to being in a state where it's completed, okay? And you want to test after every time you do something so that you can find out what a bug is and try to fix it before you move on to something more complicated.